video is going to cover the four main topics for our Science CBA. If you are following along and you do not have this in your notes, because I know one of the groups class got cut short today, probably a good idea to write down everything that's on the screen as we talk through it. So there's going to be four main topics that are going to be covered on the CBA. First topic is weather or climate. So most of the questions involved with weather or climate are either going to be comparing statements, whether or not the statement is an example of weather information or climate information, or it will be some analysis of some weather data, whether that be some weather maps or data tables with temperature or other weather information, rain information, that kind of thing. So let's talk about the difference between weather and climate. So weather is conditions, and those conditions, when I say conditions, I mean things like rain, wind, temperature, those kinds of things. So it's conditions that are happening, and when I say happening, that could be happened or will happen at a specific time. And that's the big key, is that it's happening at a specific time. And so some of the key words that we're looking for weather are days like today. Today it was sunny and clear. Tomorrow it is going to rain. Yesterday was very windy. The days of the week, I'm just going to put one down. Just put Sunday. On Sunday, the high temperature was 64 degrees. So any words like that, today, yesterday, tomorrow, the days of the week, or even larger blocks of time, like last week or this week. Now, when you get into year and month, that's where it gets a little bit, it's a little bit confusing, because if it's talking about specifics, for example, if I said that last year it rained a total of 67 inches in, I don't know, Chicago, Illinois. That's an example of weather, because I'm talking about a specific time frame. All right. If I say the average rainfall in Chicago last year was 7 inches a month, now we get to talking about climate, because climate, still dealing with conditions. So the conditions are the same. So things like rain, wind, temperature, but it's conditions that are averaged. And so if you can think of it as, since it's an average, that's telling us what usually happens. It's usually hot in Texas during the summer months. It's usually cold in Alaska during the winter months. We're just saying what it's usually like. We're not being specific. So for climate, it's not a specific time frame. It's just telling us what usually happens. And really those two words, averaged and usually, those are our two big keywords. All right. Now the other big thing we need to know for weather and climate is we need to be able to read and interpret weather graphs and weather maps. And we don't have to do a lot with this. Primarily we're looking at cold fronts and rain, because those cold fronts represent changes in temperature, and typically those cold fronts also represent rain. So if we've got a cold front, actually, you know what? Well, no. I was going to use blue, but since probably your exam will be black and white, we'll just use black and white. Black marker is dying. All right. So when a cold front moves in, so if here, this is us in Mansfield, Texas. Cold front moves in. What that means is we've got cold air moving in. And since this air is cold, and really colder, there's not a specific temperature, it just has to be colder than the warm air that's in the area already. So we've got cold air here, and we've got warm air in here. And this cold air is going to move in the direction of the arrows. And so if this is a weather map on Sunday, if the question was, what prediction can you make about the temperature in Mansfield, Texas on Monday? Well, that's the day after. We can assume that that cold front would have moved through and that this cold air would now be covering Mansfield, Texas, and it would be colder. So we would say temperature drop. Now, a lot of times, along with the cold air, we will also see storms move through, and maybe even thunderstorms. Now, the reason for this is as the cold air moves in, this warm air, and warm air typically holds a lot more moisture than the cold air does. The warm air will actually lift up into the sky as the cold air moves underneath it, because warm air is less dense. So it will move up. We'll get a lot of rapid condensation, and then that rapid condensation will cause some rapid precipitation. And so that's why you'll get thunderstorms a lot of times when a cold front moves in. The other thing you'll need to know with weather and climate is just looking at some data tables and looking for some patterns. So if we have a temperature data table, and we've just got some days here, I'm just going to number the days 1, 2, 3, 4. And we have the temperature doing this. So the temperature is slowly increasing. And so what we want to do is we want to actually write on this data table, okay, here on day 1 to day 2 it increased 1 degree, so it went up +1. Day 2 to 3 it increased 2 degrees. 3 to 4, 3 to 4 it increased 3 degrees. And so we can start to kind of see a pattern. A lot of times the question will be, if this pattern continues, what do we expect day 5 to be? Well, we expect day 5 temperature to be 4 degrees higher than day 4, so it would be around 22 degrees Celsius. And so those are the kind of things you're going to need to know for weather and climate. All right, the next topic that we are going to look at, the next topic is going to be about the water cycle. Now, for most of you, you have been studying the water cycle for several years now. So this should be pretty common. The big focus this year, however, is how the sun interacts with the ocean in the water cycle. Now, the heat from the sun, That is a terrible arrow. So much so that I can't leave that on there. That's awful. Let's try that again. Let's just do solid. So the heat from the sun is going to cause the water to evaporate. And so we get the evaporation. And the thing about the sun we need to understand is that it is the power source. It's the battery, if you will, of the entire process. So it's powering the entire thing. And that's why typically when you start looking at the water cycle, people usually will start with evaporation. So we get evaporation, and then eventually, when that water vapor gets high in the sky, it'll form a cloud and we get condensation. Now, something we need to focus on here too is that condensation is this water vapor, this water gas, changing back into a liquid. So clouds are actually liquid. Those water droplets are so itty bitty and teeny tiny that they stay up in the air. Now, once they get big enough, and our cloud precipitates, and we get our precipitation, once that liquid gets heavy enough, that's when it precipitates and it falls back to the ground. And then once it falls to the ground, it's supposed to be land, if you can believe that. Once it falls to the ground, then we get the water moving downhill to the lowest possible point, and we call that collection. Now, the water can go a lot of different places during the collection phase. It can go into the ground, it can be absorbed by plants, it can go deep underground into groundwater. It's not always going to flow back into the ocean, but most of the water will, because that's where the majority of the Earth's water is. And the majority of the evaporation we see is over the ocean, because that's where most of the water is, and all that water is exposed to sunlight every single day. So we get massive amounts of evaporation from the ocean. All right. Next topic we're going to look at is the Earth's rotation. Now, the Earth's rotation causes the day and night cycle. The Earth spinning around is what causes it to change from day to night and then from night to day. It takes 24 hours for the Earth to rotate once. Now, we looked at a lot of pictures and diagrams. I want to show you one more, mostly because this one is a little bit confusing. I have to switch out my black marker or go to a different color. So here's our sun. And on this particular graphic, we're going to be looking at the Earth from the top. Like this little dot would be the North Pole, and we're looking at the Earth from the top, looking down. So looking at that, this is going to represent the dark side or the night side of the Earth. And then this side would represent the day side. The Earth's going to rotate this direction. So it's spinning around this direction, just spinning around in a circle. Okay. I am going to use a different color for this because I want you guys to very clearly see it. So what we're going to look at is a couple of different positions. We're going to talk about what's happening at those positions. So if I was standing at this point on the Earth, all right, I would be experiencing noon. It would be midday because, let me change this. Because where I would be standing, the sun would be right over my head. And so the sun's right over my head. That's going to be midday. That's going to be noon. Now I'm going to go ahead and skip to letter C because it's the opposite, and it would actually be the middle of the night. It would be midnight. Because it's on the total opposite side. It's on the dark side. The Earth has rotated. And because of that rotation, now we're on the complete opposite side. It's night side. It's the middle of the night, which would be midnight. Now B, the Earth is rotating, and B, where we're at on B, it's on the day side, but it's about to be on the night side. So that would be the point where the sun is about to set. And then D is the opposite because it's coming back around and it's on the dark side and it's about to be on the day side. It's on the night side, fixing to be on the day side, so that would be our sunrise. A couple of other things I want you guys to remember. These are just kind of memory things. Because a lot of questions that you'll get on the day and night cycle will have to do with shadows and the Earth's position in the sky. So a couple of things to remember. The sun rises in the east, and the sun sets in the west. If shadows point west, it is morning. If shadows point east, it is afternoon. Because if a shadow, for example, if I've got that's just green. I've got a tree here. There's my tree. If I've got a tree and the shadow is over here, it's on the ground over here, then what that must mean is the sun has got to be right here. Well, if this is east, we just said that the sun rises in the east, so this is the morning sky. If it was flip-flopped and the sun was over here, the shadow would then be over here. So the sun's in the western sky and it sets in the west. So if the sun's in the western sky, it's going to be afternoon. All right, last topic. The last topic is a comparison between some of the characteristics of the Earth, the Sun, and the Moon. So what I'm going to do here, I'm going to write in 3 different colors. I'm going to write, for the Sun, I'm going to write in red. Let's do blue for the Earth. And we will do, I was going to do black for the Moon, but my black's not cooperating, so we'll just do green. All right. So we're going to look at some different characteristics and see which apply to which. So the first thing we're going to look at is orbiting. So the word orbit, you might also hear the word revolve. But if something orbits another object, then that means it is traveling around it, right? So if I've got something here in the center and I've got something traveling around it, then this thing, if it's going in this direction, it's orbiting it. It's revolving around it. And of those two, the moon orbits the Earth, and the Earth orbits the Sun. And the Sun does not orbit a specific object. Some pretty advanced astronomy, but we live in a spiral galaxy. Milky Way galaxy is a spiral galaxy, and it's spinning slowly. I say slowly; it's all relative, I guess. Um, and so technically, we're on an outer edge, and so our sun and our whole solar system is kind of spinning around it. But that doesn't really count because it's not a specific object. Um, and if you really get into some advanced astronomy, you'll learn that everything in the universe is moving in all kinds of crazy directions all at once. It's very, very fun, but also a little confusing. But for our purposes in fifth grade science, we don't need to know all that. We just need to know that the Earth, it orbits an object, the Sun, and the Moon orbits an object, the Earth. The Sun is the only one of the three that generates or produces energy. The other two do not produce or generate energy. The Earth's core has a lot of energy, but the Sun has actually got nuclear fusion occurring all the time, which is generating energy. And the energy inside the Earth is energy that's really been stored there. It's not being produced. There's no nuclear explosions happening in the Earth's core or anything. It's really hot. There's a lot of energy down there, but no new energy is being created. All right. The Earth is the only one of the three that has liquid water. So we found ice on the moon, but it's in a solid form. So the water's in a solid form. The Earth is the only of the three is the only one that has liquid water. Both the Earth and the moon are made mostly of rock. Sometimes you hear the word composed or composition. Composed mostly of rock. I'm actually going to change that on here too. I know that's not a word we use a lot. Composed, mostly, of rock. The moon is the only one that lacks an atmosphere. Remember the word lacks mean it doesn't have one. I have to zoom out here a little bit. Ooh, wrong way. There we go. Lacks an atmosphere. Does not have an atmosphere, the moon. The sun and the Earth both have an atmosphere. We call the sun's atmosphere the corona. The Earth's atmosphere is the only one that has oxygen. So the atmosphere has oxygen. I'm going to go ahead and put this under here. I'm going to squeeze this in here. Because they are made mostly of rock, we find that the Earth and the Moon both have mountains. Now those mountains are formed in very different ways. Mountains on the Moon were formed mostly from crater impacts, and the mountains on the Earth formed mostly from tectonic plate movement, but they both still have them. They're just made in slightly different ways. All three are spherical in shape. One of the few things all three of them have in common. And then the last characteristic, and it's interesting, but a lot of students get confused by this, is the Earth is the only one that has fossil fuels under the surface. Kind of got squished in there. It's the only one that's got fossil fuels under the surface. And a lot of students will mistakenly think that the moon has fossil fuels underneath the surface, but it doesn't, because remember, fossil fuels form from the remains of dead plants and animals. Well, the moon has never had any plants and animals to die and get buried um, and eventually, because of the pressure and the heat, form into fossil fuels. So the Earth is the only one that has fossil fuels, and that's a pretty common mistake. Some students will pick the moon. All right, ladies and gentlemen, if you have got the information in this video down, then you are going to be good to go on our assessment tomorrow. So good luck. Remember, if you haven't written this stuff down, write it down. If you need to go back through and view it a couple of times, do it. Be ready for this test tomorrow. We should do well on it.